Hi, this is Dr. Gopal Reddy, and our today's topic is synthesis of sigma bonded organometallic compounds. So let us see. So what are the possibility of types of reactions happening in organometallic compounds while
So
preparing
here I'm going
sigma
to
bonded
discuss few
compounds? Common reactions among that one is oxidative addition, reductive elimination, migration elimination, insertion. So these are the few reactions commonly happen in the organometallic compounds. That mean when ligand is approaching to central metal atom. So these are the possibility of possible reactions. Let us discuss one by one. So first, if we consider the oxidative addition. So oxidative addition, as this terminology indicates, oxidative addition. So when we add the ligand to the metal atom, so the metal atom is undergoing for oxidation. So a reaction in which usually a neutral ligand adds to a metal center, in doing so oxidizes the metal. So as I told, so oxidation of metal atom happening when we add the ligand. The transferring of two electrons from the metal to the incoming ligand breaks the bond in that ligand, forming two new anionic ligands. So that means if the metal atom is undergoing for oxidation means, so metal atom should be give up the two electrons to the ligand. See now here one complex one we consider. So this metal ligand N, where N may be the coordination number, it will be varies. So when we had the neutral ligand to the this metal atom, so this metal atom is contributing these two electrons to this ligand, and it will be break up into what are two anionic ligands. Here it will be break up. So when it need to break up this, so these two electrons are coming from what? So metal atom, one is 2x and one is 2y, and these two, once it is break up, so these two anion ligands will be coordinating to metal atom at a different sites. This is called as oxidative addition. We are adding this ligand, neutral ligand, to the metal atom while the metal atom is undergoing for oxidation. So with example I will discuss in the next slide. And the second is reductive elimination. So again the same terminology implies the same meaning. So when we eliminate the ligands, so it will undergo for reduction means it's gaining of electron, so opposite to the oxidation. So here metal atom is giving up the two electron, but in this, so while the ligand is eliminating, so the metal atom will be gain the electrons. So it is reverse of that. A reaction in which two cis-orbital anionic ligands on a metal center couples together. Each anionic ligand pushes one electron back onto the metal center to reduce it by two electrons. That means, so when this complex is the organometallic compound, so this X and Y is cis to each other. That means that they are lying on the same side of this metal atom. So then what happened? They coupled each other, this ligand and this ligand, and they are eliminating, they are removing, maybe because maybe that we can see later what is either beta elimination, alpha elimination, so or what it may be. So then if they're while they are eliminating each other, so on this X is pushing one electron to metal atom, and this Y is also pushing one electron to this metal atom. That means this ligand and this ligand are both together is contributing two electrons to this metal, and these will be coming as so together as XY. So and it will be forming, so that here these two anionic ligands are contributing two electron, and as metal is gaining electron, two electron, it undergo for reduction. That means so gain of electrons, that is called as reductive elimination, as the metal undergoing for reduction, so and while eliminating the ligands, this is called as reductive elimination. And the third type of reaction is migratory insertion. So this is also implies the same meaning, migratory insertion. First what happened, the ligand and the metal will be a migration to the another place, and the insertion will be happening together. A cis-orbital anionic and a neutral ligand on a metal complex coupled together to generate a new coordinate anionic ligand. See now here, so on the M, R is there, Z is there. Then first what they do is they coupled together, that is like what a RZ, and they will be coordinating central metal ion as a together. that will be discussed with the example. And here what happened, there is no withdrawing the electron density from the metal atom or to the donating the electron density to the metal atom, and the metal oxidation state will be remain same, that there is no change in the oxidation state or d electron count of the metal center, but overall electron count on the metal decreases by 2 electron. Why? Because that will be removing pulling the electron density for the bonding. So here, so one ligand, another ligand, they couple together, and then so insertion will be taking place as a new ligand to the metal atom. In the previous slide, that is alkyl halides. So this is a strong oxidizing agent. Here alkyl halide I consider it is a strong oxidizing agent. Even it is 18 electron also, it can be make it react. So then what happen? This can form what are electronegative substance, because CH3Br methyl bromide, it can be split as Br minus and the CH3 plus, and has the lone pair of electrons are present in the iridium. Then what happen here, it carbon plus positive charge will forming, this can be linked to here. So and here what happen, insertion of what a methyl group is taking place as forming what a over positive charge. Then the another side, this Br minus is there, so this can be coordinating from the other hand. Then what happen, automatically this one ligand from here and one ligand from here, as it is coordinating, so its oxidation state will be changes as the coordination number changes. So here coordination number is 4, here if you see this final compound, the coordination number is 6, so the oxidation state will be changes, that is iridium, so 3, and the total number of electrons also becomes 18 here, that we can be calculate. So from what this chart we can given, so that is can be calculate either from two methods I given, one is neutral method and another one is oxidation method. This is called as oxidative addition of reactive substrate, because this is what we consider electrophilic nature ligands, because this can form easily, so CH3 and Br minus. This is exactly opposite to the oxidative addition. This is the reductive elimination. Here elimination is taking place by undergoing the metal atom per reduction. See now here one H here, one H here, these two are undergoing for elimination. See now here on elimination, first the migration will be taking place here. So iridium 18 plus 3 is there, oxidation state with 18 electron rule, and here also the migration of H plus with the H is taking place here, and which can form the almost the coupled each other and form the H2. And then what happened, these together it is eliminating from the metal atom. So while it is eliminating, so it is contributing 2 electrons uh, to the iridium, because each this hydrogen will be donating 1 electron, and this hydrogen atom is donating 1 electron. So thus both the electrons, the 2 electrons are donating to the IR. So hence it will becoming what 16 electron, and the oxidation state also reduces to so +1. This is called as reductive elimination. So where oxidation state is dropped from what higher to lower, as it is gains the electron while eliminating the so H2 molecule together. And here another example, another type of reaction, that is migratory insertion. So again here first in on the metal organometallic compounds, so the ligands will be taking place the migration, and then insertion will be taking with the another ligand. See now here, so what I highlighted with the this blue one, CO group and CH3 group. So on first what happened, this CH3 is migrating to the neutral ligand, that is onto the carbonyl group, so which will be coupling together and leaving this is as a vacant. And as this is remains as vacant, and another ligand we are going to add, because ligand addition, so this on addition of the ligand, this will be directly will go and link bind to the metal atom on the vacant orbital, while the CH3 group is undergo for migration. Migration means what is moving from here to here. And now this once migratory is done, then insertion will be taking place on the same site here. See now here, what is the L we are adding here? That L is linking to metal atom on the place of migration, where CH3 group is taking place the migration here. So here in this case there is no change in the electrons here, but in the migration it taking place, but 2 electrons are reduced, but on ligand is thinking here that maintain the same electrons here. See now here anionic, this common anionic and neutral ligands are undergo a migratory insertion with one another, that is anionic ligands are here and neutral ligands are given here. What is migration? The anionic ligand is move on to the neutral ligand. Know that anionic site always bind to the neutral ligand here. So we are adding the ligand, and here the ethyl group is no, neutral ligand, and this CH3 group is linked to the this one ethylene group, and here palm water propyl group, and again we are adding one more alkene group. Again it will be extend because this will be linked to heart this one here, so it will be extending the its bond formation, because this is become neutral ligand here, and this is becoming anionic, and this will be hand up with this one and forming water, so new compound. So I'm repeating again. So this is zirconium complex, this is CH3 group is there. When we had the CH to this alkene group, this is neutral, so this is anionic, this is linked to this end, and it will be extend the bond, and this is the new compound will be generating. And further addition of what another alkene group, this is neutral ligand and this is anionic group, so this is linked to this end and it will be extending this one, so this will be a type of bonding will be forming. Okay, so alkene and hydride usually react via migration of hydride to coordinate the alkene ligands. The reverse reaction is called as beta elimination. So the I will show. So beta hydride elimination means, see now here in this metal hydride complexes, so any metal here the CH3 H group is there, beta elimination. So this will be linked binding to here. There will be double bond is forming on this. So this is a double bond formation is there. And alpha hydride elimination, again this will be move on to here, and there will be double bond is forming on here. And similarly carbonyl elimination or decarbonylation, so here also, so there will be a CO group is forming, and where R is linking to metal atom. Okay, so this is one of the hardest elimination reaction with breaking of CC bond. Okay, these are the pure reactions which are involved in the so preparation of sigma bond in the organometallic compound. Keep on listening.